Hello, 7th grade. First lesson of our new chapter. We're going to be learning about electromagnetic waves. So our first lesson is on the nature of electromagnetic waves. So let's look at the My Planet Diary. This time it's a blog from Justin. So Justin writes, electromagnetic waves are used in everyday life. Some examples are phones, iPads, scales, and supercomputers. Imaging machines such as MRIs, CAT scans, X-rays, and ultrasound allow us to detect abnormalities in the body. Electromagnetic waves help us with jobs, school, and medical problems. They make life easier by shortening time needed to do things. Phones allow us to speak to relatives in different states. Supercomputers help us monitor the shuttles in space. So how do electromagnetic waves make Justin's life easier? The simplest way is that they let him speak to relatives in different states. So our key questions are what makes up an electromagnetic wave and what models explain how electromagnetic waves behave. So what is an electromagnetic wave? I'm going to put myself all the way down here at the bottom so you can see all the words. An electromagnetic wave is a transverse wave that involves the transfer of electric and magnetic energy. An electromagnetic wave is made up of vibrating electric and magnetic fields that move through space or some medium at the speed of light. So it can begin with the movement of charged particles, all of which have electric fields around them. As the particles change speed or direction, a vibrating electric field is created, which in turn produces a vibrating magnetic field. The magnetic field creates an electric field, and they produce each other repeatedly. So continuing on, they continue to produce each other. Electromagnetic radiation is energy that electromagnetic waves transfer through matter or space. And my bubble again. Two different models are needed to explain the behavior of electromagnetic waves. A wave model best explains many of the behaviors, but a particle model best explains others. So when light passes through a polarizing filter, it has the properties of a wave. Polarized light is light that has been filtered so that all of its waves are parallel to each other. So think of light waves like transverse waves on a rope. They vibrate in all directions. So if you were to take a rope through a fence that has vertical slits, so up and down slits, only the waves that vibrate up and down will pass through because you're shaking the rope up and down. The other waves are blocked from going through. A polarizing filter acts like the slits in a fence. It only allows waves that vibrate in one direction to pass through it. Sometimes light behaves like a stream of particles. Photoelectric effect is the ejection of electrons from a substance when light is shined on it. And a photon is a tiny packet of energy. The photoelectric effect can be explained by thinking of light as a stream of tiny packets or particles of energy, also known as photons. For the effect to occur, each photon must contain enough energy for the effect to occur, each photon must contain enough energy for an electron to free it from the metal. Let me just double check on that here. Hold on. Sorry, that should be knock. To knock an electron free from the metal. And let's look at our vocabulary words. We have electromagnetic wave, a transverse wave that involves the transfer of electric and magnetic energy. Electromagnetic radiation, energy that electromagnetic waves transfer through matter or space. Polarized light, which is light that has been filtered so that all of its waves are parallel to each other. Photoelectric effect, the ejection of electrons from a substance when light is shined on it. Photon, a tiny packet of energy. And your assignment is going to be working on the modal questions for lesson 1. If you have any questions, let me know.